Hello everyone, my name is Viraj and today we'll be looking at the 26th problem from the CP-31 sheet by TLE Eliminators under the 1000 rated questions. Let's go. So I've moved on to my sheet, ticked off 1000 and 26th problem, buying torches. Let's read this. You are playing a very popular game called CubeCraft. Initially you have one stick and you want to craft K torches. One torch is crafted using one stick and one coal. You have met a very handsome wandering trader who has two trade offers. Exchange one stick for X sticks, as in you lose one stick and you gain X. Exchange Y sticks for one coal, as in you lose Y sticks and gain one coal. During one trade, you can only use one of these two trade offers. You can use each trade offer any number of times you want in any order. Your task is to find the minimum number of trades you need to craft so that you have at least K torches. The answer always exists under the given constraints. You have to help answer T independent test cases. All right, so let us generalize this problem quickly. It is all about calculation and mathematics. We have been told that you have one stick with you initially, okay? And you're trying to create K torches. A torch is made up of one stick, and one coal. Now you have two operations which you can perform. They are calling this trades, but you can simplify and say operations. Operation number one says that if you have one stick, you can give it and instead get X sticks back. Operation 2 says if you have Y sticks, you can actually take them and get one coal back. Now, the question is, using the least amount of operations like these, either one or two or club, whatever you want, in any order, by the way, how can you get at least K torches? Okay, this is the question. Now, at least over here means greater than equal to K. So even if you create exactly K torches, that is fine. That is why in the first place, I think I said we want to make K torches. So you make K, K plus 1, K plus 2, that's absolutely fine. You want at least K torches. All right, so I'll show you the process and simulation on test case number 1, and I think we'll understand what is the answer. So 2, 1, 5. That means X is given 2, Y is given 1, and K is given 5. You want 5 torches. Now, initially you have one stick that is already there with you. So I'll show you the operations. What we can do is, when we exchange this one stick and do operation kind 1, we basically give this one stick and we get how many back? We get 2 sticks back. Now, if you give 1 and you get 2 back, then what's the net change? When you have given 1 stick to somebody and you take 2 back, then you have personally gained just 2 minus 1, that is 1 stick. So you can say that when you do operation kind 1, your stick count will go to 2. Next time you will do again operation kind 1, stick count will go to 3. Then again operation kind 1, this goes to 4. Then operation kind 1, this goes to 5. Then operation kind 1, this goes to 6. Then operation kind 1, this goes to 7. Then operation kind 1, this goes to 8. And so on, 9. And then 10. So I have performed these many operations. I now have 10 sticks. This is basically trade 1 or the option 1. Now what I'll do after this is, I have 10 sticks with me. From 10 sticks, I'll actually perform trade number 2. That is, I'll give how many sticks? I'll give one stick, that is Y equals to 1 value. I'll give one stick and actually get back one coal. So now my sticks go to 9 because I have used up one stick, but I have actually gained one coal. You can keep that in your mind. We'll come to that back. Again do operation 2. Now you have, you can say 8 sticks, operation 2, 7 sticks, operation 2, you have 6 sticks, and then operation 2 finally, and you have 5 sticks. Okay. Now, when you see this, overall, what has now happened, you have 5 sticks left. And remember, you did the second operation 5 times. So that means you would have gained 5 coal. Like by this basis, you also gained 5 coal. Now, if you have 5 sticks and you have 5 coal, do you think you can combine one stick and one coal together to create one torch? So you have 5 sticks, you have 5 coal, combine both of them together, you get 5 torches back. And K was given as 5. So don't you think you have created at least 5 torches for yourself? You have. And if you count the number of operations you did so, You did 1, 2, 3, 4, 5, 6, 7, 8, 9. Then 1, 2, 3, 4, and 5. You basically did 9 plus 5, that is 14 operations to get back at least 5, or in this case, exactly 5 torches. And if you go back, the answer is actually 14. So now you have a good simulation of how and where did this 14 come from. I hope this helps. Now you can pause the video and see the other cases. They might be a little large, especially the last two, but you can try to figure out the answers for the 2 and 3 case, so that maybe you actually wound up getting an idea. And if so not, let's actually continue. I think the problem is clear and the test cases is clear. We just have to somehow figure out how do we create exactly or at least k torches in that scenario. Why am I saying exactly more and more is because you're looking to minimize the number of trades overall. So we would genuinely prefer that we exactly make k torches rather than going for a statement that is at least k torches, because you anyways are happy with k torches also. All right, I hope this is clear. Let us move on. So now what is the expected time in this? One test is giving me 1 second. And then there are test cases also that are given in every test. That is in 2 into 10 raised to 4 order. So I can write like this. One test basically tells me that create something in 10 power 8 order of operations. But operations for every test case will be something like 10 power 8 upon 2 into 10 raised to 4. That is roughly going to be like 5 into 10 raised to 3 operations. Now if I go back and see for x, y, and k, they're actually very large values, 10 power 9 order. Now, when we actually saw the simulation, this is 10 power 9 order. When we actually saw the simulation, we actually did this addition on the number of sticks and then finally coming back to the trades and going for the second type, then getting back goals and everything. But if these values would have been so high, do you think you can actually perform this? Like, do you think you can actually run a while loop in this? That's not possible. That means I don't want to create solutions that are linear in this case, like O of x, or basically like saying O of 10 raised to 9. Something like this is not promoted. Even you cannot go anything higher than this, of course. Linear times are not there. We know by experience that if constraints are this high, we are looking for something that is almost practically constant or maximum log power or something like that. That means all of this is not promoted. We are looking for something like a log solution, else we are looking for something that is constant. So all of this is something that we want, and all of this is not going to work. And this is my expected time complexity, which is now very fruitful because now I know that, okay, look for some mathematics. Why? Because if you want any constant, any log solution, you would probably wound up with some formula analysis over here, because either way, you of course cannot simulate this whole coal and stick and finally torch creation. I hope this helps. Great. So now we'll actually go to our main approach. When we have discussed the expected time complexity, it's clear we're looking for a formula. So let's try to analyze the whole thing that we're trying to achieve and see if we can come up with some formula over here. First of all, k torches are what we are trying to create. Or in this case, we are trying to create at least k torches, but I think this idea should be greedily clear that if we create exactly k torches also, I think we are good to go. So if we look to create exactly k torches, we need k coals and we need k sticks. Now first I'll focus on coal. Why? Because initially you have a stick with you, but you actually don't have a coal. Coal can only be generated from sticks. Sticks can be generated from sticks because if you give one stick, you will get sticks back. But coal can only be generated from sticks. Now if you have Y sticks, which end up giving you one coal, and by simple unitary method, you can say if you need k coals, you will be needing Y into k sticks. So if I ask you how many sticks do you right now want for getting k coals, you'll be like k into Y. I hope this helps. Now k into Y is the number of sticks you need for finally getting k coals. On top of that, you already need k sticks beside this. So you want k normal sticks because k sticks that is over here will also be required to make k torches. Right now you have just created coals out of this. So you need these k sticks added. And then remember, if I talk about the initial phase of our problem, we already have one stick with us. So would I not want that if I try to ask you what's the overall amount of sticks you finally want so that you are able to create k torches, you'll be like, okay, k into y to create k coals. So that is k into y sticks. K sticks normally so that I actually can put them for creating k torches, and I already had one stick. So k into y plus k is the requirement, minus 1 is already what I had. This is the final amount of needed sticks. I hope this helps. This is the final amount of needed sticks. Now I have figured out that I want k into y plus k minus 1 sticks, but I actually had one stick in the very beginning. So that means I need to use operation kind 1 to increase my stick count. It goes from 1 to some value. If I use operation 1, how many times is that required? Let's talk about one trade over here. They are saying that when you give one stick, you basically gain x back. Now, this is something we discussed even in the test case when we saw, when you give one stick and you get x back, what is the net gain that you have actually done in your overall stick count? It's basically x minus 1. I think that is very commonsensical to write, that you basically are getting x minus 1 sticks back per trade type 1. You can say per operation type 1. And if this is actually the sticks you gain for one trade, you want to figure out the overall trade count that is required of the type 1. So you can simply say that if this is the needed stick count and x minus 1 is the per trade gain, something like this, whatever you call these variables, you would want that you calculate x into y plus k minus 1 upon x minus y sealed up value, so that you actually get the number of trade 1, allowing you to fulfill the requirement of needed sticks. And then after this, you will apply trade 2. How many times? Remember, when you have already done trade 1 number of times, you have the overall requirement of sticks, as in you have k into y sticks and you have k extra sticks for the normal case. So k into y sticks will now be converted to coal. That means you will total require k trade 2 count also to convert those k into y sticks into k coals. And after the accumulation of both of these values, you will now be left with k coals and k sticks. And then they have not told you in the story that is combining both of them also an operation. It's just producing k coals and k sticks is fine, because then that's automatically noted that if there are k coals and k sticks, you have automatically created k torches for yourself, and we wanted at least k torches, so this is going to work out. All right, now a small point to discuss over here would be, you might think, why the seal value? For example, let's say you would have just wanted 10 by, like if this fraction would have turned out as 10 by 4 and you would have done a floated division, 10 by 4 would have actually landed you with 2. That means you would have done 2 trades. Now, if you do 2 trades, do you think you will get 10 sticks back? No, you will get a little lesser than 10 because you remove the decimal part. So make sure that when you do 10 by 4, you actually don't boil this down to 2, but rather you make it sealed up to 3. So if you do 3 trades of the trade type 1, only then you will get at least 10 sticks to work with. And when you have at least 10 sticks to work with, for example, only then you might be able to create the required coals also back, and then finally the required number of torches also. Again, this is just an example. So this part should be clear that we are not looking to float this value, rather we're looking to seal this value. Let's go point by point once more in this idea. We started off by saying that there are k torches. That means we want k coals and k sticks. Now we have one stick already. I figured out what are the overall sticks count I want. Why did I do that? Because I knew that coals can only be generated from sticks, although sticks can reproduce sticks themselves by trade 1. So I need to first figure out the overall stick count, because from that I might be able to get the required coals also and leftover sticks also to cumulatively get k torches. So I said, if you want k coals and y sticks give 1 coal, that means k into y sticks will give me k coals. So this is the stick count I required to generate k coals. Then k normal sticks should be there with me so that I can plug them over here. And then 1 stick is something I already have. So k into y plus k minus 1 became the overall sticks needed. Then one trade of the type 1 gave me x minus 1 sticks as a gain. So I said this value by this value sealed up would be the number of trades 1 I do in order to produce the needed amount of sticks. Now, in this needed amount of sticks, I finally will have this k into y sticks already. So I can take them out and give them in the trade type 2 so that I actually get k coals back. So that would be added k more trades. And overall, after I complete all this process, I would end up with k coals and k sticks so that I actually have the accumulation as k torches, which satisfies greater than equal to k requirement. All right, and this is my main idea. So now let us try to run this on one of the larger cases, probably like 2 and 3, and we'll run on both of them actually to see whether our idea checks out. 43, 13, 24. So you have 43 as x, y is 13, and k is actually 24. Now let's actually plug the formula. K into y plus k minus 1. So 24 into 13 plus 24 minus 1 upon x minus 1, that is 42 minus 1, that is 41. We want the seal of this value. Now you can actually pause this video and pick up your calculator. You will actually see that this value turns out as 9. Okay, I hope this is fine. And after this, I said that you would again require 24 more trades of type 2. So this is like type 1 and then this is type 2. So type 1 plus type 2, that is the overall trade count, and that is the minimum possible because we are always focusing to create exactly k torches. So 9 plus 24, this turns out as 33. All right, and let's go back. Is 33 our answer for the second case? Yes, it is. So I think the idea checks out. Let's do this once more on the case number 3. You had 11, 12, 11. Sorry, 12, 11, 12. Now plug y into k, that means 11 into 12 plus k, that is 12 minus 1 upon x minus 1, that is 11, sealed up value. Pause the video and actually you will see that this turns out as 13. And then you want 12 more trades of the type 2. So 12 plus 13 gives you 25. And is this your answer? Yes, 25 was your answer. All right. So I hope the idea and everything over here is helping you. And this is basically the whole problem. It's all about mathematics. Now you can actually figure out that, okay, in our respective time complexity also we discussed we wanted something constant, and doing all of this is going to take constant time because we're not simulating the problem. Rather, we came up with a very neat approach where we have actually figured out how do we quickly get the number of trade 1s required, the number of trade 2 requires, and that are overall the minimum since we targeted k torches. That was the least one to satisfy our condition. So trade 1 plus trade 2 overall gets me the best answer possible. All right. Now all that is left there is to implement this out. Before you actually implement this out, I want to share with you a very small idea that is usually very helpful. When we actually try to create A by B seal value, when you try to calculate this out in code format, one way to of course do this is you make A and B double and you put the seal function and all that part. But besides that, the other way to neatly do this so that you avoid all those decimal errors that can happen, A by B sealed roughly translates to A plus B minus 1 upon B as float, or if you just remove float symbol over here, that's natural integer division, A plus B minus 1 by B. And this is actually the formula I'm going to use so that I actually come up with the exact value of trade 1 and avoiding all the precision errors that can happen. Why am I doing this is because I can see that X and Y all are pretty large. They are in 10 power 9 orders. So if everything is 10 power 9, I might actually end up with something that is in 10 power 18 order because of the multiplications that are also there, divisions also that are there. So I don't want to lose any precision. It's best to use neat mathematics with us, which is by default there in C++, integer division. Okay, so I'll be plugging that formula also. You can note this from this video onwards that this is a very, very useful formula to be applied in order to avoid all those seal and point and all those plugins that you might actually have to do in your code. Okay, this is what we finally want. Let us go to our code piece and we'll see how to implement this. So this is my code structure. As first of all explained, I have this seal division function which takes A and B, and then I return A plus B minus 1 by B. So that is actually the thing I want. So I've defined this above. How do I use this? Let's see. Test cases input X, Y, and K. Then sticks gained per trade. That is, if we give 1 stick, we get X back. So how do we gain? We get X minus 1 stick. So I have defined that variable. Now sticks needed. That is, if 1 torches 1 stick plus 1 coal, K torches K stick plus K coal, then we need the sticks count as K into Y plus K minus 1, already minus 1 because we had only 1 stick. So sticks needed, sticks gained per trade. Let's do something. We have the overall trade count. First, let's increment this by trade 1 types, that is seal division of sticks and sticks gained per trade. This is of type trade 1, and then added to that plus K again of the trade type 2, that is using required stick to get K coal. If we print this overall value, that is trades, we actually run all the cases nicely. And you can see even on the larger values, this is going to work fine. That is test case number, I think, 4 and 5. So the idea definitely checks out. Okay, now this is again my implementation advice that we do this way. If you think you can do this in any other way, that's fine. The crude idea is you need some mathematics because simulation was, as we discussed, not possible. Now, how about discussing the time complexity? No use, it's actually pretty much constant because as we know that we are taking no loop or anything like that into picture. We just have creation of variables and then quick calculation, all is elementary. So this is O of 1. And what is space complexity? Also O of 1. So a very neat problem and a very neat solution. All right. So I hope the mathematics works out with you. Pause the video, go through the whole problem once again if you want, and make sure that you imagine and you're able to check out why is this k into y plus k minus 1 coming out. And then I think the problem should be fairly easy for you. All right. So this is all that is there in this problem. I hope you like the video. Thank you for watching.